Welcome to my channel. Today in this session, let us discuss something about the steady state error. Right? Error is defined as the difference between the actual output towards the desired actual input towards the desired output. Okay. So this is known as the error definition. Right? Here I have a summer and the input and feedback is H of s just fed back to the error detector, right? So the input E of s is given as the R of s divided by 1 plus G of s H of s. By applying the final value theorem, the steady state error equation will be ESS is equal to limit S tends to 0 S E of s, which is equal to limit S tends to 0 S into R of s 1 divided by 1 plus G of s H of s. So already we have discussed about the final value theorem, right? And also we have discussed about the initial value theorem. Okay, those who are not seen that, please go come across that and come to the next class, right? So the actual output points to be discussed related to the steady state error are the actual output of the control system may be in physical form. It is called as position or displacement. If it is in the physical form, it may be known as the physical position or displacement. The first derivative of the actual output is known as velocity and second derivative is known as acceleration. So the actual output of the control system is given maybe in the form of position or in case of velocity or in case of acceleration, right? So the position, velocity and acceleration with respect to the physical quantities, the E, I and theta is given as for position it is E, I, theta only, and for provided physical parameters, the first derivative is velocity, and for E I theta, the first derivative is given as dE by dt, di by dt, and d theta by dt. And the second derivative of acceleration is given as d square theta and d square E by dt square, d square I by dt square, and d square theta by dt square, right? So with this discussion, let us see about the static error coefficients of such as position, velocity and acceleration, right? For evaluating the static error coefficient of the position, velocity and acceleration, we have some specified inputs such as step, ramp and parabolic, right? For positional error coefficient, that is static positional error coefficient, when the input is step input, the positional error Kp is given by the steady state error equation as this is our steady state equation, and we need to substitute the input R of s. By substituting the input R of s in this steady state error equation, ESS is equal to limit S tends to 0, S into 1 by S into 1 by G of S H of S. This and this get cancelled, right? So we have the steady state error equation as 1 divided by 1 plus limit S tends to 0, G of S, H of S. Here I am considering the positional error value as limit S tends to 0, G of S, H of S. My steady state error for the provided step input 1 by S, I have one positional error. Then the positional error is given as ESS, which is equal to 1 plus Kp, right? So Kp is nothing but limit S tends to 0, G of S, H of S. This is the input for, this is the error coefficient for the positional error, right? Similarly, While discussing towards the velocity error coefficient, my input is ramp input and my static error coefficient is denoted by notation kV. Right? Positional error coefficient is denoted by notation kV. Right? And the input is given as R of S is equal to 1 by S square. Right? By substituting this, I get S and S square, I get S. S is wholly multiplied. I get the equation as kV is equal to limit S tends to 0, S into G of S, H of S. This is my kV value. So, I substitute the 0 here for the S term and I have the value 1 divided by S into G of S, H of S. I consider this as the kV. That means my velocity error coefficient. So, steady state error for this equation is nothing but ESS is equal to 1 divided by kV. Right? This is my steady state error coefficient for the provided input. And similarly for the acceleration error, I get the also for I give the input as the parabolic input and I have an acceleration coefficient as Ka is equal to S square G of S H of S. The parabolic input I take here is 1 divided by S cube. And substituting in the steady state error, my ESS will be equal to ESS is equal to 1 by K. So, we have examined the three different cases. That means the steady state error coefficient, positional error, velocity error and the acceleration error. And for the provided case, we need to check which is applicable to the type, which type of the system, right? The type of the system which we have discussed already, and the type is nothing but it is provided by the highest order coefficient of S term, right? So, type of the system and the order of the system we have discussed already. We have discussed about the type 0, type 1 and type 2 systems, and for the different types and which error coefficient is applicable we need to discuss. Okay, so let us discuss once again from the starting. We have discussed about the positional error and the steady state error of positional error coefficient is given by 1 divided by 1 plus kp, and for the velocity error steady state error is given by 1 divided by kv, and for the acceleration error ess is equal to 1 divided by kv. So for the provided input, if the inputs are unit step and ramp and parabolic. These are the provided input, and for the provided input, if it is a type 0, what type of error is there? If it is type 1, what type of error is there? If it is type 2 system, what type of error is there? Right? So, unit step input is given by 1 by S. Ramp input is given by 1 by 1 S square. Parabolic input is given by 1 by S cube. Okay. And the steady state error ESS for type 0 is, as discussed earlier, it is nothing but 1 divided by 1 plus Kp. That is 1 divided by 1 plus Kp. And steady state error for on type 1, sorry, positional error for type 1 is not applicable. So I am putting this as 0, and type 2 system is also 0. Since we have Kp which is equal to K, right? And Here, for type 1 system, Kp is equal to infinity. While substituting for this equation, ESS is equal to 1 divided by 1 plus Kp. Kp here is equal to infinity. 1 divided by infinity, which is equal to 0 for the type 1 system. Right? And for type 0 system, Ka, this is our steady state error equation, and type 0 system, Kv equal to 0 and velocity error constant is equal to 0. We have the type 0 system steady state error as infinite, and type 1 system steady state error is equal to Kv, and type 2 0 system, which is 0. And for the parabolic input provided, type 0 system, it is infinite, and type 1 system, it is infinite, and type 2 system, it is Ka. So, from this table, we come to know that unit step input positional error is only in the case of type 0 system, and type 1 type 2 system is 0. And for the RAM system, there will be, it is applicable only for the type 1 system, and type 0 system will be infinite, type 2 system will be 0. And for a parabolic input, type 0 system and type 1 system will be infinite, and type 2 system will be 1 by Ka. That means ES steady state error, which is equal to 1 by Kv for velocity, and type 0 system, which is 1 by 0 Kv, which is equal to 0. So we get the type 0 system as infinite, right? So, well, thorough with this table, this may be asked as the objective while we are preparing for the cancer gate examinations, right? So, one more point which we have to discuss relevant to this is just you can get the input as unit input, and you are asked to check the steady state error simply. This is simple case. Well, know with this, if the unit step input is given, there will be an error constant, positional error constant, and also this will be in the type 0 system. If ramp input is given, the velocity error constant, this will be in the case of type 1 system, and in case of acceleration error, it is in the case of type 2 system. Rather than other things are infinite before the type 2 system, after the type 2 system other things are 0. We have more number of type of systems, or here be for discussion we have taken only three different types. That means the type 0, type 1 and type 2. Be thorough with this table for your preparations. If you like this video, like, share and subscribe.